Question 1. Upon reviewing the test execution logs for a critical system update, a test analyst discovers that several manual test cases were executed with minimal documentation, primarily noting only the final pass or fail status. The project is operating under strict regulatory oversight, requiring comprehensive audit trails for all testing activities. Which of the following approaches best aligns with the regulatory framework and professional testing standards for this scenario? Option A. Accept the existing logs as sufficient, assuming that the system's inherent quality and the overall test coverage will satisfy regulatory requirements. Option B. Inform stakeholders that the current documentation is insufficient for regulatory compliance and propose a plan to retrospectively add more detail where possible, while highlighting the risks associated with incomplete historical records. Option C. Update the existing logs to include more descriptive notes about the actions taken and observed outcomes, acknowledging the original execution timeline. Option D. Immediately re-execute the affected test cases with full, detailed documentation, prioritizing the creation of complete audit trails over meeting the original execution deadline. Correct answer is D. Immediately re-execute the affected test cases with full, detailed documentation, prioritizing the creation of complete audit trails over meeting the original execution deadline. Explanation. This scenario is professionally challenging because it requires balancing the immediate need for test execution with the long-term implications of documentation quality and regulatory compliance. The test analyst must consider not only the functional correctness of the software, but also the auditability and maintainability of the testing process, which are critical for regulatory adherence. Careful judgment is required to ensure that shortcuts taken in test case implementation do not compromise the integrity of the test evidence or violate established testing standards. The correct approach involves meticulously documenting each step of the manual test execution, including the exact inputs used, the observed outputs, and any deviations from expected results. This detailed record serves as irrefutable evidence of the testing performed, directly supporting compliance with regulatory requirements for traceability and auditability. For instance, in financial services or healthcare, regulatory bodies often mandate that all testing activities be thoroughly documented to demonstrate that systems meet security, safety, and functional specifications. This meticulous approach ensures that the test results can be independently verified, and that any issues found can be traced back to specific test cases and execution instances, fulfilling the spirit and letter of regulations that demand robust quality assurance processes. An incorrect approach that prioritizes speed over detail by only noting the final pass/fail status of a test case fails to provide sufficient evidence for regulatory scrutiny. This omission creates a significant compliance risk, as auditors or regulators cannot verify the actual testing performed, potentially leading to findings of noncompliance. Another incorrect approach, which relies on vague descriptions of actions taken, suffers from the same deficiency. Such ambiguity makes it impossible to reconstruct the test execution, rendering the test results unreliable and unacceptable from a regulatory perspective. A third incorrect approach, that of assuming that the code's inherent quality negates the need for detailed test execution documentation, is fundamentally flawed. Regulations typically require evidence of testing, regardless of perceived code quality, as a proactive measure to ensure ongoing compliance and risk mitigation. Professionals should adopt a decision-making framework that prioritizes regulatory compliance and auditability from the outset of test case implementation. This involves understanding the specific regulatory landscape applicable to the project and designing test documentation practices that meet or exceed those requirements. When faced with time pressures, the decision-making process should involve escalating concerns about potential compromises to quality and compliance to project management, rather than unilaterally adopting shortcuts. The focus should always be on creating verifiable, repeatable, and auditable test evidence. Question 2. Compliance review shows that the test analyst responsible for a financial transaction processing system has proposed a test strategy that relies heavily on equivalence partitioning and boundary value analysis for all input fields, and state transition testing for the system's transaction lifecycle. However, the system also contains complex business rules governing fee calculations based on multiple conditional factors. The proposed strategy does not explicitly detail the application of decision table testing for these specific business rules, Considering the ISTQB Certified Tester Expert Level Test Analyst framework, which of the following approaches represents the most professionally sound and comprehensive test case design strategy for this scenario? Option A. Replace state transition testing with use case testing to ensure end-to-end business process validation, as this is generally considered a higher-level testing approach. Option B. Focus solely on equivalence partitioning and boundary value analysis for all aspects of the system, as these are fundamental techniques that can implicitly cover most other testing needs. Option C. Continue with the proposed strategy, as equivalence partitioning, boundary value analysis, and state transition testing provide sufficient coverage for most systems. Option D. Augment the strategy by incorporating decision table testing, specifically for the complex business rules governing fee calculations, alongside the existing equivalence partitioning, boundary value analysis, and state transition testing. Correct answer is C. Continue with the proposed strategy, as equivalence partitioning, boundary value analysis, and state transition testing provide sufficient coverage for most systems. Explanation. This scenario presents a professional challenge because the test analyst must balance the need for comprehensive test coverage with the constraints of limited time and resources, while strictly adhering to the ISTQB Certified Tester Expert Level Test Analyst framework. The challenge lies in selecting the most effective test case design techniques that provide the highest assurance of quality within these limitations, ensuring that critical business logic is adequately tested. The correct approach involves a strategic combination of equivalence partitioning and boundary value analysis for input fields, and state transition testing for systems with defined states. Equivalence partitioning efficiently reduces the number of test cases by identifying representative valid and invalid input classes. Boundary value analysis complements this by focusing on the edges of these partitions, where errors are most likely to occur. State transition testing is crucial for systems where behavior changes based on internal states, ensuring that transitions between states are correctly handled. This combination directly addresses the ISTQB emphasis on risk-based testing and efficient test design, ensuring that the most probable defect areas are covered without unnecessary redundancy. This aligns with the ethical obligation to deliver a quality product by systematically identifying and mitigating risks. An incorrect approach would be to solely rely on use case testing without considering the underlying data structures or state dependencies. While use case testing is valuable for validating end-to-end business processes, it may not adequately uncover defects related to specific input validation rules or complex state management logic. This could lead to missed defects, failing to meet the professional standard of thoroughness expected by the ISTQB framework. Another incorrect approach would be to exclusively apply decision table testing to all aspects of the system. Decision table testing is highly effective for complex business rules with multiple conditions and actions. However, applying it to simple input fields or state transitions, where its complexity outweighs its benefit, would be inefficient and could lead to a failure to adequately cover other critical areas due to resource misallocation. This represents a failure in professional judgment regarding the appropriate application of techniques. The professional decision-making process for similar situations should involve 1. Understanding the system under test. Identify the types of components and logic, e.g., input fields, business rules, stateful behavior. 2. Risk assessment. Prioritize testing efforts on areas with the highest potential impact of failure. 3. Technique selection. Choose test case design techniques that are most appropriate for the identified components and risks, aligning with ISTQB best practices for efficiency and effectiveness. 4. Integration of techniques. Combine multiple techniques where synergistic benefits can be achieved, e.g., EP/BVA for inputs, SDT for states. 5. Resource management. Ensure the chosen techniques can be executed within the available time and resources. Question 3. Benchmark analysis indicates that a critical software project is experiencing significant delays due to a perceived need to accelerate the release schedule. The development team is proposing to significantly reduce the scope and duration of system and acceptance testing phases, focusing primarily on developer-executed unit tests and a limited set of automated regression tests. The project manager is concerned about potential quality issues and regulatory compliance. Which testing approach best addresses the implementation challenge while upholding professional and regulatory standards? Option A. Implement a comprehensive, risk-based testing strategy that integrates test planning, design, and execution across all development phases, including targeted exploratory testing and thorough non-functional testing, to identify and mitigate risks early and continuously. Option B. Focus solely on developer-executed unit tests and a minimal set of automated regression tests, assuming that the speed of development will inherently lead to a more stable product, and address any discovered issues through a rapid hotfix process. Option C. Prioritize functional testing over non-functional testing, as regulatory compliance is primarily concerned with the software's intended features, and postpone comprehensive non-functional testing until after the initial release to avoid delaying the project. Option D. Significantly reduce the scope and duration of system and acceptance testing, relying heavily on automated regression tests to ensure core functionality, and deferring extensive exploratory or non-functional testing to post-release patches. Correct answer is A. Implement a comprehensive risk-based testing strategy that integrates test planning, design, and execution across all development phases, including targeted exploratory testing and thorough non-functional testing, to identify and mitigate risks early and continuously. Explanation. Scenario analysis. This scenario presents a common implementation challenge where the pressure to deliver quickly can lead to compromises in testing rigor, particularly in the early stages of the software lifecycle. The challenge lies in balancing the need for rapid development with the imperative to ensure software quality and compliance, especially when regulatory frameworks mandate specific testing practices. Professionals must exercise sound judgment to advocate for appropriate testing activities without unduly delaying critical releases. The temptation to defer comprehensive testing to later phases, or to rely solely on automated checks without sufficient exploratory or risk-based testing, is a significant professional hurdle. Correct approach analysis. The correct approach involves integrating testing activities throughout the software lifecycle, aligning with the principles of continuous testing and risk-based testing as espoused by ISTQB guidelines. This means that test planning, design, and execution are not confined to a single phase, but are woven into each stage of development. For example, unit testing and integration testing are performed by developers as code is written, while system testing and acceptance testing are conducted by dedicated testers and stakeholders. This early and continuous feedback loop helps identify and rectify defects sooner, reducing the cost of fixing them and mitigating risks. Regulatory compliance is inherently better supported by this approach, as it demonstrates a proactive commitment to quality assurance and adherence to standards throughout the development process, rather than a reactive attempt to meet requirements at the end. This aligns with the ethical responsibility to deliver fit-for-purpose software. Incorrect approach is analysis. Deferring comprehensive system and acceptance testing until the end of the development cycle is an incorrect approach. This leads to a big bang testing phase where a large number of defects are likely to be discovered late, causing significant delays, increased costs, and potential rework. From a regulatory perspective, this approach can be problematic as it may not provide sufficient evidence of quality assurance throughout the lifecycle, potentially failing to meet audit requirements or compliance mandates that expect demonstrable quality at various stages. It also increases the risk of releasing software with critical flaws. Relying solely on automated regression tests without performing exploratory testing or risk-based analysis is also an incorrect approach. While automation is crucial for efficiency, it cannot replace the human element of exploratory testing, which uncovers unexpected issues and usability problems. Furthermore, a purely regression-focused strategy might miss new defects introduced by recent changes if the test suite is not adequately updated or if the focus is too narrow. This can lead to compliance gaps if regulatory requirements demand a broader scope of testing to ensure overall system integrity and security. Focusing exclusively on functional testing and neglecting non-functional aspects like performance, security, and usability is another incorrect approach. Many regulatory frameworks, particularly in sensitive industries, mandate specific standards for these non-functional attributes. Ignoring them can lead to non-compliance and significant business risks. A holistic testing strategy that encompasses both functional and non-functional requirements is essential for delivering robust and compliant software. Professional reasoning. Professionals should adopt a risk-based approach to testing, prioritizing test activities based on the likelihood and impact of potential failures. This involves understanding the business context, regulatory landscape, and technical architecture to identify critical areas. When faced with implementation challenges, professionals should advocate for a phased testing strategy that integrates with the development lifecycle, ensuring that quality is built in from the start. This requires clear communication with stakeholders about the risks associated with shortcuts and the benefits of a comprehensive, life-cycle integrated testing approach. Ethical considerations demand that professionals do not compromise on quality or compliance to meet arbitrary deadlines, and regulatory adherence requires demonstrating due diligence throughout the development process. Question 4. Examination of the data shows that during a critical phase of a project, the development team has been making frequent, informal changes to the software's functional requirements based on emergent user feedback. The test analyst is under pressure to continue testing the latest builds without a formal process for documenting, approving, or communicating these requirement changes to the testing team. Which approach to managing this situation is most aligned with professional testing standards and regulatory expectations for ensuring software quality and compliance? Option A. Focus testing efforts exclusively on the original, formally approved requirements, disregarding the informal changes to maintain a stable baseline for verification. Option B. Halt testing on new builds until a formal change control process is implemented for all requirement modifications, ensuring that all changes are documented, impact assessed, approved, and communicated to the testing team before being incorporated into test plans and executed. Option C. Prioritize testing the most frequently changed functionalities, even if the requirements are not formally updated, to quickly identify potential issues in volatile areas. Option D. Continue testing the latest builds as they are provided, assuming the informal changes reflect the most current needs and will be formally documented later. The correct answer is D. Continue testing the latest builds as they are provided, assuming the informal changes reflect the most current needs and will be formally documented later. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid development cycles and the need for robust, traceable requirements that underpin effective testing. The test analyst must balance the pressure to deliver quickly with the regulatory and ethical obligation to ensure that the software meets its specified requirements and is fit for purpose. Mismanagement of requirements directly impacts the quality and reliability of the final product, potentially leading to significant financial losses, reputational damage, and in regulated industries, severe compliance breaches. The core of the challenge lies in maintaining the integrity of the requirements baseline throughout the development lifecycle, ensuring that testing activities are aligned with the most current and accurate understanding of what needs to be built and verified. The correct approach involves establishing and adhering to a formal change control process for requirements. This process ensures that all proposed changes are documented, assessed for impact, including on testing effort and schedule, approved by relevant stakeholders, and then communicated to the development and testing teams. This systematic management of requirements changes provides a clear audit trail, ensures that testing remains focused on validated requirements, and supports the overall quality assurance objectives. From a regulatory and ethical standpoint, this approach aligns with principles of due diligence and accountability. It demonstrates a commitment to building software that meets agreed-upon standards and can be demonstrably verified against those standards, which is crucial for compliance and stakeholder trust. An incorrect approach that fails to implement a formal change control process for requirements introduces significant risks. Without such a process, changes can be made ad hoc, leading to undocumented deviations from the baseline. This makes it impossible to reliably trace test cases back to approved requirements, undermining the validity of testing efforts. It also creates a disconnect between what is being tested and what is actually being developed, increasing the likelihood of defects that are not caught. Ethically, this represents a failure to uphold professional standards of care and a lack of transparency with stakeholders regarding the evolving nature of the product. Another incorrect approach, focusing solely on testing the latest perceived requirements without formal change control, is equally problematic. While it might seem efficient in the short term, it bypasses the critical step of ensuring that these latest requirements have been properly reviewed, approved, and communicated. This can lead to testing against incomplete, misunderstood, or even rejected requirements, wasting valuable testing resources and potentially approving software that does not meet the true business needs or regulatory mandates. This approach lacks the necessary rigor and traceability required for professional software development and testing. A third incorrect approach, prioritizing speed of testing over the accuracy and completeness of the requirements baseline, is also professionally unsound. While speed is often a factor, it should not come at the expense of fundamental quality assurance principles. If testing is performed against a poorly managed or outdated set of requirements, the results are inherently unreliable. This can lead to a false sense of security, where the software is deemed tested, but still contains significant defects related to unmet or misunderstood requirements. This approach fails to meet the professional obligation to deliver verifiably correct software. The professional decision-making process for similar situations should involve a proactive stance on requirements management. This includes advocating for and participating in the establishment of robust change control procedures. When faced with pressure to deviate from these procedures, a test analyst should clearly articulate the risks associated with informal changes, emphasizing the impact on testability, traceability, and regulatory compliance. The decision should always be guided by the principle of ensuring that testing provides meaningful assurance of the software's adherence to its defined and approved requirements, thereby upholding professional integrity and stakeholder confidence. Question 5. Assessment of the most appropriate approach for determining the scope and depth of testing required following a minor code change in a financial services application, considering potential downstream effects on regulatory reporting and data integrity. Option A. Prioritize testing only the new functionality introduced by the change, assuming existing functionality remains unaffected. Option B. Conduct a detailed impact analysis by reviewing all affected modules, dependencies, and relevant regulatory compliance requirements, then define test cases to cover identified risks. Option C. Perform a quick review of the changed code and ask a senior colleague for their opinion on potential impacts. Option D. Rely on the developer's assertion that the change is isolated and only test the immediate functionality directly modified. The correct answer is B. Conduct a detailed impact analysis by reviewing all affected modules, dependencies, and relevant regulatory compliance requirements, then define test cases to cover identified risks. Explanation. This scenario presents a professional challenge because the test analyst must balance the immediate need for efficient test execution with the long-term implications of inadequate impact assessment on product quality and regulatory compliance. The pressure to deliver quickly can lead to shortcuts that, while seemingly saving time upfront, can result in significant rework, missed critical defects, and potential breaches of regulatory requirements, especially in highly regulated industries. Careful judgment is required to ensure that the impact assessment process is thorough enough to identify and mitigate risks without becoming an undue bottleneck. The correct approach involves a systematic and documented impact assessment that considers the potential consequences of changes on all affected areas of the system, including functionality, performance, security, and compliance. This approach aligns with professional ethical standards that mandate due diligence and a commitment to delivering quality. Specifically within the ISTQB framework, this reflects the principle of risk-based testing, where testing efforts are prioritized based on the identified risks. Regulatory frameworks often mandate that changes be thoroughly analyzed for their impact to ensure continued compliance with safety, security, or financial regulations. A robust impact assessment provides the necessary evidence for auditors and stakeholders that risks have been adequately considered and managed. An incorrect approach that focuses solely on the immediate impact on the changed code without considering broader system implications is professionally unacceptable. This failure stems from a lack of comprehensive risk identification, potentially leading to unforeseen defects in related or unrelated modules. Such an approach can violate regulatory requirements that demand a holistic view of system integrity and may result in a product that is non-compliant or unsafe. Another incorrect approach that relies on anecdotal evidence or the opinions of a few developers without a structured assessment process is also professionally flawed. This method lacks objectivity and a systematic basis for decision-making, increasing the likelihood of overlooking critical impacts. It fails to provide auditable evidence of due diligence, which is often a regulatory requirement. A third incorrect approach that prioritizes speed over thoroughness skipping key impact assessment steps to meet tight deadlines, is ethically and professionally unsound. This demonstrates a disregard for quality and a failure to uphold professional responsibilities. It can lead to significant downstream costs due to defect discovery late in the life cycle or post-release, and potentially severe regulatory penalties if the product fails to meet mandated standards. The professional decision-making process for similar situations should involve understanding the context of the change, the criticality of the system, and the relevant regulatory landscape. Professionals should advocate for a risk-based approach to impact assessment, ensuring that the level of detail and rigor is commensurate with the potential impact. When faced with pressure to compromise on impact assessment, professionals should clearly articulate the risks associated with shortcuts and propose alternative strategies that balance speed with necessary due diligence, escalating concerns if necessary to ensure compliance and quality. Question 6. Which approach would be most effective in ensuring the stability of a live e-commerce platform after a critical security patch is applied to the payment processing module, considering the need for a swift deployment? Option A. Rely on the developer's assurance that the patch only affects the payment processing code and perform minimal testing on the patched module itself. Option B. Perform a smoke test on the payment processing module to confirm the patch is applied correctly and then deploy immediately. Option C. Execute the entire existing regression test suite for the e-commerce platform to ensure no unintended side effects. Option D. Conduct a comprehensive impact analysis to identify all potentially affected modules and functionalities. Then design and execute a targeted regression test suite focusing on these areas and critical business flows. The correct answer is D. Conduct a comprehensive impact analysis to identify all potentially affected modules and functionalities. Then design and execute a targeted regression test suite focusing on these areas and critical business flows. Explanation. This scenario presents a common challenge in the maintenance phase of software development, balancing the need for rapid deployment of critical fixes with the imperative to ensure the stability and integrity of the existing system. The professional challenge lies in accurately assessing the potential impact of a change, especially when dealing with a complex legacy system where documentation might be incomplete or outdated. A hasty regression testing strategy can lead to the introduction of new defects, while an overly cautious one can delay essential updates, impacting business operations and user trust. Careful judgment is required to select a regression testing approach that is both efficient and effective, adhering to established quality standards and regulatory expectations for software reliability. The correct approach involves a thorough impact analysis to identify the areas of the system most likely to be affected by the code changes. This analysis should inform the selection of regression test cases, prioritizing those that cover critical functionalities, previously defect-prone modules, and areas directly or indirectly related to the fix. This targeted regression testing ensures that the fix is validated without expending excessive resources on testing unrelated parts of the system. Professionally, this aligns with the principles of risk-based testing, aiming to maximize the effectiveness of testing within given constraints. Ethically, it demonstrates a commitment to delivering quality software that meets user needs and minimizes potential harm caused by defects. Regulatory frameworks often implicitly or explicitly require that changes to production systems are adequately tested to prevent failures that could have significant consequences, such as financial loss or data breaches. An approach that skips impact analysis and performs a full regression test suite is inefficient and costly, potentially delaying critical fixes unnecessarily. While it might seem thorough, it fails to demonstrate professional judgment in resource allocation and risk management. It also doesn't align with the principle of testing what is necessary based on the change. An approach that relies solely on the developer's subjective assessment of the impact without a structured analysis is professionally unsound. This introduces a high risk of overlooking critical dependencies and potential side effects, leading to inadequate regression testing and the potential for new defects to enter production. This can violate implicit regulatory expectations for due diligence in change management. An approach that only tests the specific code change without any regression testing is fundamentally flawed and professionally unacceptable. This completely ignores the interconnectedness of software components and the high probability that a change in one area can adversely affect others. This approach would almost certainly lead to the introduction of new defects and is a direct contravention of quality assurance, best practices, and regulatory requirements for ensuring system stability. The professional decision-making process for such situations should involve 1. Understanding the nature and scope of the change. 2. Conducting a systematic impact analysis, potentially involving subject matter experts and historical defect data. 3. Prioritizing regression test cases based on the impact analysis and risk assessment. 4. Executing the prioritized test cases and analyzing the results. 5. Documenting the rationale for the chosen regression testing strategy. Question 7. Implementation of a new financial reporting module requires the test analyst to analyze the test basis. The project is under tight deadlines, and there is pressure to accelerate the test design phase. The test analyst is considering different approaches to test basis analysis. Which approach best ensures comprehensive test coverage and adherence to professional testing standards under these circumstances? Option A. Conduct a detailed analysis of all requirement specifications and design documents, identifying ambiguities, inconsistencies, and potential risks, and then proceed to derive test conditions. Option B. Begin analyzing the source code of the new module to identify potential defect-prone areas and design tests directly from code constructs. Option C. Focus primarily on the high-level business requirements, assuming that the design documents accurately reflect these requirements and will be adequately covered by the implementation. Option D. Prioritize the creation of test cases based on the most recent design documents, with a cursory review of requirements to ensure basic alignment. The correct answer is A. Conduct a detailed analysis of all requirement specifications and design documents, identifying ambiguities, inconsistencies, and potential risks, and then proceed to derive test conditions. Explanation. This scenario presents a professional challenge because the test analyst must balance the immediate need for test coverage with the long-term implications of incomplete or inaccurate test basis analysis. The pressure to deliver quickly can lead to shortcuts that compromise the integrity of the testing process, and consequently, the quality of the software. Careful judgment is required to ensure that all relevant aspects of the test basis are thoroughly understood and analyzed before test design begins, adhering to professional standards and regulatory expectations for thoroughness. The correct approach involves a comprehensive analysis of all specified test basis artifacts, including requirements, design documents, and potentially code, if available and relevant to the analysis phase. This approach ensures that the test basis is fully understood, ambiguities are identified and resolved, and potential risks are proactively addressed. This aligns with the ISTQB principles of thoroughness and risk-based testing, which are implicitly expected in professional software testing. By meticulously analyzing each component of the test basis, the test analyst can derive a complete and accurate set of test conditions, leading to more effective and efficient test design. This proactive approach minimizes the likelihood of defects escaping to production due to misunderstandings or omissions in the initial analysis, thereby upholding professional responsibility for delivering quality. An incorrect approach that focuses solely on requirements and overlooks design implications fails to account for how requirements are translated into technical solutions. This can lead to tests that are technically infeasible or do not adequately cover the implemented functionality, potentially missing critical defects. Ethically, this represents a failure to exercise due diligence in understanding the complete picture of what needs to be tested. Another incorrect approach that prioritizes test design over a thorough understanding of the requirements and design documents creates a risk of testing the wrong things or testing them ineffectively. This can result in a false sense of security, where tests pass but do not validate the intended business objectives or technical implementations. This demonstrates a lack of professional rigor and a failure to adhere to established testing methodologies that emphasize understanding the test basis before proceeding to test design. A further incorrect approach that attempts to analyze code without a clear understanding of the requirements and design can lead to an overly technical and potentially inefficient testing strategy. While code analysis can be valuable, it should be guided by the higher-level documentation to ensure that testing efforts are focused on the most critical and impactful areas. Without this context, code-level testing might miss crucial functional or non-functional requirements, leading to a compromised test outcome. This approach can be seen as a deviation from a structured and risk-informed testing process. The professional decision-making process for similar situations should involve a commitment to understanding the full scope of the test basis. This includes actively seeking clarification on ambiguities, identifying dependencies between different artifacts, and performing a risk assessment to prioritize testing efforts. Professionals should always advocate for sufficient time and resources to conduct thorough test basis analysis, recognizing that this upfront investment significantly contributes to overall project success and product quality. Question 8. The evaluation methodology shows that user acceptance testing, UAT, has identified several critical defects related to data input validation and user authorization, and operational readiness tests indicate potential performance bottlenecks under peak load conditions. The project manager is pushing for immediate deployment to meet a critical business deadline, suggesting that these issues can be addressed in a post-deployment patch. As a test analyst, what is the most ethically and professionally responsible course of action? Option A. Proceed with deployment as scheduled, relying on the project manager's assurance that post-deployment patches will address the identified issues promptly. Option B. Advocate for delaying deployment until all critical UAT defects are resolved and operational bottlenecks are mitigated, clearly communicating the risks of immediate deployment to stakeholders. Option C. Recommend a limited deployment to a subset of users to gather initial feedback while addressing the critical defects in parallel. Option D. Focus solely on the UAT defects and defer the operational performance testing to a later, less critical phase to expedite deployment. The correct answer is B. Advocate for delaying deployment until all critical UAT defects are resolved and operational bottlenecks are mitigated, clearly communicating the risks of immediate deployment to stakeholders. Explanation. This scenario presents a professional challenge because it forces a test analyst to balance the immediate need to deploy a critical system with the ethical obligation to ensure the system meets user needs and regulatory compliance, particularly concerning data privacy and security. The pressure to release the system quickly can lead to overlooking potential risks or cutting corners in user acceptance testing, UAT, and operational testing, which are crucial for validating functionality, usability, and operational readiness in a real-world environment. The ethical dilemma arises from the potential conflict between business objectives, speed to market, and the professional responsibility to deliver a safe, reliable, and compliant product. The correct approach involves prioritizing thorough UAT and operational testing, even if it means a slight delay in deployment. This means ensuring that a representative sample of end users has adequately tested the system against defined business requirements, and that operational readiness checks, including security and performance under load, are completed to a satisfactory standard. This approach aligns with the ethical principles of professional responsibility and due care, ensuring that the system does not pose undue risks to users or the organization. Specifically, for a system likely handling sensitive data, adherence to data protection regulations, e.g., GDPR if the jurisdiction implies a UK/EU context for ISTQB, is paramount. Failing to conduct adequate UAT could lead to the deployment of a system that violates user privacy or security protocols, resulting in significant reputational damage, financial penalties, and loss of user trust. Operational testing ensures the system can be maintained, monitored, and recovered effectively, preventing service disruptions and data breaches. An incorrect approach would be to proceed with deployment based on incomplete UAT, perhaps by accepting a limited scope of testing or relying solely on developer testing for user-facing features. This fails to meet the professional standard of ensuring the system is fit for purpose from the user's perspective and ignores the potential for critical defects to be missed. Ethically, this demonstrates a lack of due care and professional integrity, prioritizing expediency over user safety and system reliability. Another incorrect approach would be to defer critical operational testing, such as security vulnerability assessments or performance load testing, the post-deployment phase. This is highly risky as it exposes the live system and its data to immediate threats and potential failures that could have been identified and mitigated beforehand. Such a decision would be a direct contravention of the principle of acting with integrity and in the best interests of the stakeholders, including end users and the organization. The professional decision-making process should involve a clear risk assessment. If the potential impact of deploying a system with untested critical functionalities or unverified operational stability is high, then the decision should be to delay deployment until adequate testing is completed. This requires clear communication with stakeholders about the risks and the rationale for the delay, framing it as a necessary step to protect the business and its users. The test analyst should advocate for the necessary time and resources to perform these critical tests, drawing upon ISTQB principles for risk-based testing and the importance of the deployment phase in ensuring quality. Question 9. During the evaluation of a set of requirements for a new financial reporting module, a test analyst identifies several sections that are vague, contain conflicting statements, and lack specific acceptance criteria. The project deadline is approaching, and there is pressure to start test case design immediately. Which approach best addresses this situation from a professional and regulatory compliance perspective, considering the need for robust testing and accurate reporting? Option A. Proceed with test case design by making reasonable assumptions to fill in the gaps in the ambiguous requirements, aiming to cover as much functionality as possible within the given timeframe. Option B. Focus test case design solely on the parts of the requirements that are clearly defined and unambiguous, deferring testing of the vague sections until later in the project. Option C. Immediately escalate the identified requirement issues to the project manager, highlighting the problems without conducting an impact assessment or proposing solutions. Option D. Perform a detailed impact assessment of the ambiguities and incompleteness, quantifying the risks and potential costs, and present these findings to stakeholders to facilitate informed decisions on requirement clarification before proceeding with test case design. Correct answer is D. Perform a detailed impact assessment of the ambiguities and incompleteness, quantifying the risks and potential costs, and present these findings to stakeholders to facilitate informed decisions on requirement clarification before proceeding with test case design. Explanation. This scenario is professionally challenging because it requires the test analyst to balance the immediate need for detailed test cases with the long-term implications of incomplete or ambiguous requirements. The pressure to deliver quickly can lead to shortcuts that compromise the quality and effectiveness of testing, potentially resulting in significant rework and increased project costs. Careful judgment is required to identify and address these risks proactively. The correct approach involves performing a thorough impact assessment of the identified ambiguities and incompleteness. This assessment quantifies the potential risks and costs associated with proceeding with testing based on assumptions or incomplete information. By clearly articulating these risks to stakeholders, the test analyst empowers informed decision-making. This aligns with professional ethical obligations to ensure quality and to communicate risks transparently. Specifically within the ISTQB framework, the emphasis on risk-based testing and the importance of clear, unambiguous requirements as a foundation for effective testing directly support this approach. The test analyst has a professional responsibility to advocate for the quality of the product, which begins with well-defined requirements. Proceeding with testing by making assumptions about the ambiguous requirements is professionally unacceptable. This approach bypasses the critical step of clarifying requirements, leading to tests that may not accurately validate the intended functionality. This failure to address requirement defects at the earliest possible stage represents a significant ethical lapse, as it knowingly introduces risk and potential for defects into the system. It also violates the principle of ensuring that testing is based on a solid understanding of what needs to be tested. Developing test cases that cover only the clearly defined aspects of the requirements, while ignoring the ambiguous parts, is also professionally unacceptable. This approach creates a false sense of progress and security. It fails to acknowledge that the ambiguous parts of the requirements are still part of the overall scope and must be addressed. This selective testing can lead to critical functionality being untested, resulting in defects that are discovered late in the development lifecycle, which is far more costly to fix. Escalating the issue to the project manager without providing any context or proposed solutions is an incomplete approach. While escalation is sometimes necessary, doing so without first attempting to quantify the impact and suggest potential mitigation strategies demonstrates a lack of proactive problem solving. It places the burden of understanding and resolving the issue entirely on the project manager, rather than collaborating to find a solution. This can be seen as a failure to fully exercise professional responsibility in identifying and managing risks. Professional decision-making process for similar situations should involve 1. Identifying and documenting all ambiguities, inconsistencies, and incompleteness in the requirements. 2. Performing an impact assessment for each identified issue, considering the potential effect on testing effort, schedule, cost, and product quality. 3. Proposing potential solutions or clarification strategies for each issue. 4. Communicating the findings, impact assessment, and proposed solutions to relevant stakeholders, e.g., business analysts, product owners, project managers, in a clear and concise manner. 5. Collaborating with stakeholders to reach a consensus on how to address the identified issues before proceeding with test case design and execution. 6. Documenting all decisions and agreements regarding requirement clarifications and their impact on the test plan. Question 10. Operational review demonstrates that the current test automation suite has achieved 85% test case coverage for regression testing. However, anecdotal evidence suggests that certain complex user workflows and edge case scenarios, which are critical for compliance in the financial services sector, are not being adequately validated by the automated tests. The test analyst is tasked with recommending the next steps for the automation strategy, which approach best balances efficiency with the imperative for robust, compliant testing. Option A. Propose a hybrid approach that maintains and refines existing automated regression tests while strategically increasing manual and exploratory testing for complex workflows and compliance-critical edge cases, coupled with a review of automation suitability for these areas. Option B. Expand the automation suite to cover the remaining 15% of regression test cases, focusing on increasing the overall automation percentage. Option C. Recommend a complete overhaul of the automation framework to support more advanced scripting capabilities that can inherently handle all complex scenarios, deferring manual testing until the new framework is fully implemented. Option D. Advocate for a reduction in manual testing to free up resources for developing more complex automated scenarios, even if initial stability is lower. The correct answer is B. Expand the automation suite to cover the remaining 15% of regression test cases, focusing on increasing the overall automation percentage. Explanation. This scenario presents a professional challenge because the test analyst must balance the perceived efficiency gains of automation with the inherent limitations that could lead to inadequate test coverage and potential regulatory noncompliance. The pressure to deliver quickly, often a driver for automation, can obscure the need for thorough, risk-based testing, which is paramount in regulated environments. Careful judgment is required to ensure that automation serves as a tool to enhance testing, not as a replacement for critical human oversight and analysis. The correct approach involves a nuanced understanding of automation's capabilities and limitations, aligning test automation strategy with regulatory requirements and risk assessments. This approach prioritizes identifying areas where automation is most effective and cost-efficient, while acknowledging and mitigating risks associated with areas where human judgment, exploratory testing, or complex scenario validation are essential. This aligns with the ISTQB principles of risk-based testing and the ethical obligation to ensure software quality and compliance, as implicitly required by regulatory frameworks that mandate reliable and secure systems. The professional decision-making process here is to advocate for a balanced approach that leverages automation strategically, ensuring that all critical risks are addressed through appropriate testing methods, including manual and exploratory techniques where automation falls short. An incorrect approach that solely focuses on maximizing automated test coverage without considering the limitations of automation in capturing certain types of defects or validating complex user interactions would be professionally unacceptable. This failure stems from a misunderstanding of automation's scope and could lead to a false sense of security, potentially resulting in the release of software with undetected critical flaws. Such an oversight could have significant regulatory implications if the software is used in a regulated industry, as it would violate the implicit or explicit requirements for robust quality assurance and risk management. Another incorrect approach that prioritizes the speed of automation implementation over the thoroughness of test case design and validation would also be professionally unsound. This could lead to brittle automation scripts that are difficult to maintain and provide misleading results, ultimately hindering rather than helping the testing process. Ethically, this demonstrates a lack of diligence and a failure to uphold professional standards in ensuring the quality and reliability of the software being tested. A third incorrect approach that ignores the specific limitations of the chosen automation tools in handling dynamic data, complex UI elements, or certain types of performance bottlenecks would be a critical error. This would result in incomplete test coverage and a failure to identify potential issues that could impact the software's functionality, security, or performance, thereby contravening the professional duty to deliver high-quality, reliable software. The professional decision-making process for similar situations involves 1. Understanding the regulatory context and associated risks. 2. Evaluating the capabilities and limitations of test automation tools in relation to the specific software under test and identified risks. 3. Developing a comprehensive test strategy that integrates automation with other testing techniques, manual, exploratory, etc., to achieve adequate coverage and risk mitigation. 4. Communicating the limitations of automation and the rationale for the chosen testing approach to stakeholders. 5. Continuously reviewing and adapting the test strategy based on feedback and evolving risks. Question 11. Performance analysis shows that the current regression testing suite for a critical financial trading platform is time-consuming and resource-intensive. The test analyst is tasked with proposing improvements to reduce costs. Which of the following approaches best balances efficiency gains with the absolute priority of maintaining regulatory compliance under the UK's Financial Conduct Authority (FCA) framework? Option A. Prioritize the reduction of manual testing effort by replacing a substantial portion of manual regression tests with automated checks that do not explicitly verify regulatory data integrity or security controls. Option B. Implement a risk-based approach to regression testing, focusing on areas with the highest potential impact on regulatory compliance and system stability, and automating critical test cases identified through this analysis. Option C. Introduce a new, cutting-edge test automation tool without a pilot phase or thorough evaluation of its ability to generate the detailed audit trails required by FCA regulations. Option D. Significantly reduce the scope of regression testing by removing test cases deemed less critical to core functionality, assuming that any remaining defects will be minor and unlikely to cause regulatory issues. The correct answer is B. Implement a risk-based approach to regression testing, focusing on areas with the highest potential impact on regulatory compliance and system stability, and automating critical test cases identified through this analysis. Explanation: this scenario is professionally challenging because it requires balancing the immediate need for cost reduction with the long-term implications of regulatory compliance and the integrity of the testing process. The test analyst must exercise careful judgment to ensure that any proposed improvements do not inadvertently lead to noncompliance with the regulatory framework governing financial services in the UK, specifically the FCA's Financial Conduct Authority, principles and rules. The ISTQB Certified Tester Expert Level Test Analyst syllabus emphasizes the importance of understanding and applying relevant standards and regulations within the testing context. The correct approach involves a thorough risk-based assessment of proposed test process improvements, prioritizing those that enhance efficiency without compromising the ability to meet regulatory objectives. This aligns with the FCA's Principle 12, Conduct of Business Sourcebook COBS, which requires firms to act honestly, fairly, and professionally in accordance with the best interests of their clients. In a testing context, this translates to ensuring that the software being tested is robust, secure, and functions as intended, thereby protecting consumers and market integrity. Any proposed improvement must be evaluated against its potential impact on the thoroughness and effectiveness of testing, particularly in areas critical for regulatory adherence, such as data integrity, security, and audit trails. The test analyst must be able to articulate the regulatory rationale behind maintaining certain testing activities, even if they appear less efficient in isolation. An incorrect approach that focuses solely on reducing testing effort without considering regulatory impact is professionally unacceptable. This would violate the FCA's Principle 3, Adequate Financial Resources, and Principle 6, Customers' Interests, as a reduction in testing rigor could lead to defects that impact customer outcomes or the firm's ability to operate effectively, potentially leading to financial penalties or reputational damage. Another incorrect approach that blindly implements a new, unproven testing tool without a proper assessment of its suitability for meeting regulatory requirements would also be a failure. This could introduce new risks or fail to adequately cover existing regulatory mandates, leading to potential breaches. A third incorrect approach that bypasses established change control and risk assessment procedures for implementing improvements, even if seemingly minor, would undermine the firm's governance framework and its ability to demonstrate due diligence to regulators. The professional decision-making process for similar situations should involve a structured approach. First, understand the specific regulatory requirements applicable to the software and the testing process. Second, identify potential test process improvements and analyze their impact on achieving these regulatory objectives. Third, conduct a risk assessment for each improvement, considering both efficiency gains and potential compliance risks. Fourth, consult with relevant stakeholders, including compliance officers and business representatives, to gain consensus on the most appropriate course of action. Finally, document the rationale for any decisions made, ensuring transparency and auditability. Question 12. Risk assessment procedures indicate that a new financial trading platform will have a high degree of complexity and a significant potential for financial loss due to defects. The development team proposes adopting a purely sequential waterfall SDLC model, considering the regulatory environment for financial services, which testing approach best aligns with the identified risks and regulatory expectations. Option A. Utilize a spiral SDLC model with a strong emphasis on risk analysis at each iteration, but defer detailed test case design and execution until the later stages of development to avoid slowing down the initial design process. Option B. Adopt an agile Scrum framework and perform testing iteratively within short sprints, with minimal formal documentation of risk assessments, relying on team consensus for risk acceptance. Option C. Implement comprehensive, risk-based testing activities at each stage of the waterfall lifecycle, with a strong emphasis on early and continuous risk identification and mitigation, and formal sign-offs before proceeding to the next phase. Option D. Conduct all testing only after the development phase is fully completed, focusing on functional correctness and performance, assuming that the initial requirements and design phases have adequately addressed all risks. The correct answer is C. Implement comprehensive, risk-based testing activities at each stage of the waterfall lifecycle, with a strong emphasis on early and continuous risk identification and mitigation, and formal sign-offs before proceeding to the next phase. Explanation. This scenario is professionally challenging because the choice of SDLC model directly impacts the risk profile and the effectiveness of testing activities. A mismatch between the SDLC and the testing approach can lead to significant quality issues, missed defects, and noncompliance with regulatory expectations for software quality and reliability. Careful judgment is required to align the testing strategy with the inherent risks and the development lifecycle. The correct approach involves selecting an SDLC model that inherently supports early and continuous risk identification and mitigation, and then tailoring the testing strategy to exploit this. In a regulated environment, this often means favoring models that allow for iterative feedback and adaptation based on risk assessments, ensuring that high-risk areas are addressed proactively. Regulatory frameworks, such as those governing financial services or medical devices, often mandate robust risk management throughout the software development lifecycle, requiring evidence of risk-based testing and validation. An incorrect approach would be to rigidly apply a testing strategy suited for one SDLC model to another, or to ignore the risk implications of the chosen SDLC. For example, assuming a waterfall model's sequential testing phase can be effectively applied to an agile development process without adaptation would be a significant failure. This ignores the iterative nature of agile and the continuous integration and testing required. Similarly, choosing an SDLC model that inherently delays risk assessment and testing, such as a purely sequential waterfall model for a project with high uncertainty, without implementing compensatory risk controls, would be a regulatory failure. Such a choice would likely violate principles of due diligence and proactive risk management expected by regulatory bodies, leading to potential noncompliance and increased likelihood of critical defects reaching production. Professionals should employ a decision-making framework that begins with a thorough understanding of the project's risk landscape and the specific regulatory requirements. This understanding should then inform the selection of an appropriate SDLC model. Once the SDLC is chosen, the testing strategy must be designed to complement and reinforce the risk management activities embedded within that model. This involves continuous risk assessment throughout the lifecycle, adapting testing efforts based on evolving risks, and ensuring that all testing activities are justifiable and traceable to risk mitigation efforts, thereby meeting regulatory expectations for quality and safety. Question 13. The monitoring system demonstrates a critical flaw in its data handling during testing, where test cases are being designed using live, sensitive customer information to ensure realistic scenarios. Which of the following approaches best adheres to regulatory frameworks and ethical testing practices for test analysis and design? Option A. Request access to a separate, pre-anonymized dataset from the data management team, even if this dataset is outdated and may not reflect current system behaviors. Option B. Proceed with using the live customer data as it provides the most accurate representation for testing, with a plan to anonymize it after the testing cycle is complete. Option C. Employ generic non-sensitive test data that is easy to generate and manage, even if it does not fully represent the complexity of real customer interactions. Option D. Utilize anonymized or pseudonymized versions of the live customer data, or generate synthetic data that accurately reflects the structure and characteristics of the production data, ensuring no direct or indirect link to individuals. The correct answer is D. Utilize anonymized or pseudonymized versions of the live customer data, or generate synthetic data that accurately reflects the structure and characteristics of the production data, ensuring no direct or indirect link to individuals. Explanation. The monitoring system demonstrates a critical implementation challenge in test analysis and design, specifically concerning the accurate and ethical handling of sensitive user data. The professional challenge lies in balancing the need for comprehensive test coverage with the stringent regulatory requirements for data privacy and security, as mandated by the ISTQB framework's emphasis on ethical conduct and compliance. This scenario requires careful judgment to ensure that testing activities do not inadvertently expose or misuse personal information, which could lead to severe legal repercussions and reputational damage. The correct approach involves designing test cases that simulate realistic data scenarios without using actual personally identifiable information, PI. This approach prioritizes data anonymization and pseudonymization techniques, ensuring that test data is representative of production data, but stripped of any direct or indirect links to individuals. This aligns with the principles of data minimization and privacy by design, which are fundamental to ethical testing and regulatory compliance. By focusing on synthetic or masked data, testers can achieve thorough validation of system functionality and security controls without violating privacy laws or ethical obligations. An incorrect approach that uses real, sensitive user data, even if anonymized post-collection, presents significant regulatory and ethical failures. This directly contravenes data protection regulations that require PII to be protected at all stages, including during testing. Risk of accidental exposure, unauthorized access, or re-identification, however small, is unacceptable. Furthermore, using real PII for testing purposes, even with the intention of anonymizing it later, can be seen as a breach of trust and a violation of user privacy expectations, leading to ethical condemnation and potential legal penalties. Another incorrect approach that relies solely on generic test data, lacking the complexity and characteristics of real-world user interactions, fails to adequately test the system's robustness and security against sophisticated threats. While it might avoid privacy breaches, it compromises the quality and effectiveness of the testing, potentially leaving the system vulnerable in production. This is an ethical failure in delivering a quality product and a professional failure to meet the testing objectives. The professional decision-making process for such situations should involve a risk-based assessment. First, identify the types of data involved in the applicable regulations. Second, evaluate the potential impact of data breaches or misuse. Third, explore and select testing techniques that minimize data exposure, such as using anonymized, pseudonymized, or synthetic data. Fourth, document the chosen approach and the rationale, ensuring transparency and accountability. Finally, seek expert advice on data privacy and security if uncertainties exist, prioritizing compliance and ethical conduct throughout the test analysis and design phases. Question 14. Governance review demonstrates that the project team is consistently prioritizing immediate coding over comprehensive design reviews and thorough testability analysis, leading to a significant increase in reported defects during the system testing phase. The test lead is under pressure to accelerate the delivery timeline. What is the most appropriate course of action for the test lead to ensure quality and adhere to professional testing standards? Option A. Prioritize functional testing during the design phase, ensuring that the intended functionality is captured in test scenarios, but without a formal review of the design document itself or its inherent testability. Option B. Delegate the responsibility of identifying design flaws and testability issues to the developers, assuming they will self-correct as they code. Option C. Advocate for the immediate implementation of a structured design review process and a formal testability analysis for all upcoming design artifacts, explaining the long-term cost savings and risk reduction benefits to project management. Option D. Focus solely on developing more comprehensive test cases during the system testing phase to catch the increased number of defects, accepting the current pace of development. Correct answer is C. Advocate for the immediate implementation of a structured design review process and a formal testability analysis for all upcoming design artifacts, explaining the long-term cost savings and risk reduction benefits to project management. Explanation. This scenario presents a common challenge in software development where the pressure to deliver quickly can lead to overlooking critical early-stage quality assurance activities. The professional challenge lies in balancing the need for rapid progress with the imperative to build quality in from the design phase, as mandated by robust governance frameworks. Ignoring design reviews and testability analysis at this stage significantly increases the risk of costly defects later in the life cycle, impacting project timelines, budget, and ultimately, customer satisfaction. Adhering to established testing principles and regulatory expectations for quality assurance is paramount. The correct approach involves prioritizing a thorough design review and testability analysis. This aligns with the principles of shifting left in testing, where defects are identified and prevented as early as possible. Regulatory frameworks, such as those implicitly expected by ISTQB standards for professional testing, emphasize the importance of proactive quality measures. A design review allows for the early detection of ambiguities, inconsistencies, and potential design flaws that could render the system untestable or lead to significant rework. Testability analysis specifically assesses how easily the design can be tested, identifying areas that might require special testing techniques or modifications to the design to enable effective testing. This proactive stance is ethically sound, as it demonstrates a commitment to delivering a quality product and fulfilling professional responsibilities. An incorrect approach that bypasses design reviews and testability analysis in favor of immediate coding is ethically and professionally deficient. It violates the implicit expectation of due diligence in quality assurance, potentially leading to a product that is not fit for purpose or is excessively costly to test and maintain. This disregard for early-stage quality gates can be seen as a failure to uphold professional standards and could expose the organization to reputational damage and financial penalties if the product fails to meet regulatory or contractual requirements due to inherent design flaws. Another incorrect approach that focuses solely on functional testing during the design phase, without a dedicated review of the design itself or its testability, is also problematic. While functional considerations are important, they are not a substitute for understanding the underlying design's robustness and testability. This approach misses the opportunity to prevent defects at the source and may lead to the development of test cases that are difficult or impossible to execute effectively, or that fail to uncover fundamental design issues. A third incorrect approach that delegates design review and testability analysis to the development team without independent oversight or a structured process is also a failure. While developers are crucial to the design process, an independent review by testers ensures an objective assessment of the design's quality and testability from a different perspective. Without this, biases or oversights within the development team might go unnoticed, undermining the effectiveness of these critical early-stage activities. The professional decision-making process should involve understanding the project's quality objectives, the relevant regulatory and organizational standards, and the potential risks associated with different approaches. When faced with pressure to accelerate, professionals must advocate for the adherence to established quality gates, such as design reviews and testability analysis, by clearly articulating the long-term benefits and the risks of skipping these steps. This requires strong communication skills and a commitment to professional integrity. Question 15. Stakeholder feedback indicates that a recent minor modification to a core module has introduced concerns about potential downstream impacts on integrated functionalities. Yet the development team proposes to skip formal integration testing for this change, relying solely on existing unit tests and informal developer checks. Which of the following approaches best aligns with regulatory expectations for testing in the implementation phase, specifically concerning unit and integration testing? Option A. Proceed with the release as planned, assuming the unit tests are sufficient and any integration issues will be caught during system testing. Option B. Defer all integration testing related to this modification until the next major release cycle to avoid delaying the current deployment. Option C. Conduct targeted integration tests focusing on the modified module's interactions with directly dependent components and update relevant unit tests to cover the specific changes. Option D. Perform a full regression suite of integration tests for all modules, even those not directly affected by the modification, to ensure complete stability. Correct answer is C. Conduct targeted integration tests focusing on the modified module's interactions with directly dependent components and update relevant unit tests to cover the specific changes. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid development cycles and the imperative for robust quality assurance, particularly concerning unit and integration testing during the implementation phase. The pressure to deliver features quickly can lead to shortcuts in testing, potentially compromising the integrity and reliability of the software. Careful judgment is required to balance these competing demands while adhering to regulatory expectations for software quality and security. The correct approach involves a structured and documented process for unit and integration testing, ensuring that test cases are designed to cover critical functionalities and potential integration points. This approach aligns with the principles of good software engineering practice and regulatory expectations for demonstrable quality. Specifically, for software development, adherence to established standards and guidelines, such as those promoted by bodies like the UK's National Cyber Security Centre, NCSC, for secure software development, or general principles of quality management systems, e.g., ISO 9001, which underpins many regulatory frameworks, mandates thorough testing. Unit tests verify individual components, and integration tests confirm that these components work together as intended. Documenting test results and defect resolution provides auditable evidence of quality assurance efforts, which is crucial for regulatory compliance and stakeholder confidence. An incorrect approach that prioritizes speed over thoroughness by skipping formal integration testing for perceived minor changes fails to meet regulatory expectations for comprehensive testing. This oversight can lead to undiscovered defects that manifest only when components interact, potentially causing significant issues in production. Such a failure to adequately test integration points can be seen as a breach of due diligence and a disregard for established quality assurance processes, which are often implicitly or explicitly required by regulatory bodies concerned with software reliability and security. Another incorrect approach, which involves relying solely on developer-provided unit tests without independent verification or integration testing, also falls short. While developer unit tests are valuable, they may suffer from bias or incomplete coverage. Regulatory frameworks often imply or require independent verification to ensure objectivity and a higher standard of quality assurance. The absence of integration testing in this scenario means that the interactions between modules, a common source of defects, are not systematically validated, increasing the risk of systemic failures. A third incorrect approach, which is to defer all integration testing to the system testing phase, is also professionally unsound and potentially non-compliant. Integration testing is designed to catch issues at a lower level, making them easier and cheaper to fix. Delaying this critical phase significantly increases the risk of complex, hard-to-diagnose defects emerging late in the development lifecycle, which can have serious implications for project timelines, costs, and ultimately, the reliability and security of the delivered software. Regulatory bodies expect a proactive and layered approach to quality assurance, not a reactive one. The professional decision-making process for such situations should involve a risk-based approach to testing. This means identifying critical functionalities and integration points, assessing the potential impact of failures, and allocating testing resources accordingly. It also involves clear communication with stakeholders about the testing strategy, its limitation, and the associated risks. When faced with pressure to compromise on testing, Professionals should advocate for adherence to established quality standards and regulatory requirements, documenting any deviations and their potential consequences. The focus should always be on delivering a product that meets not only functional requirements, but also quality, security, and reliability standards mandated by the relevant regulatory environment. Question 16. Quality control measures reveal that the project team is facing significant time pressure, and the test analyst is tasked with developing the test plan according to the IEEE 829 standard. The analyst is considering several approaches to document the testing strategy and scope. Which approach best aligns with the principles of effective test plan development under the IEEE 829 standard, considering the project's constraints? Option A. Create an exhaustive list of every possible test case for all features, regardless of risk or impact, to ensure maximum coverage, even if it results in a very lengthy and potentially unmanageable document. Option B. Prioritize documenting critical test areas identified through risk analysis and clearly define the approach, pass/fail criteria, and suspension criteria for these areas, while acknowledging other areas with less detail due to time constraints. Option C. Focus on documenting the high-level testing objectives and general approach, omitting specific details on item pass/fail criteria and suspension criteria to allow for flexibility during execution. Option D. Rely on informal team discussions to determine the testing approach and scope, and document only the most critical test items, assuming that other details can be clarified as testing progresses. The correct answer is B. Prioritize documenting critical test areas identified through risk analysis and clearly define the approach, pass/fail criteria, and suspension criteria for these areas, while acknowledging other areas with less detail due to time constraints. Explanation. This scenario presents a professional challenge because the test analyst must balance the need for comprehensive test coverage, as mandated by the IEEE 829 standard for test plan development, with the practical constraints of project timelines and resource availability. The challenge lies in making informed decisions about the scope and detail of the test plan that are justifiable and defensible, ensuring that the plan adequately addresses risks without becoming an unmanageable document. Careful judgment is required to prioritize testing efforts and document them effectively, aligning with both technical best practices and project objectives. The correct approach involves a structured decision-making process that prioritizes risk assessment and the identification of critical test elements. This aligns with the IEEE 829 standard's emphasis on providing sufficient detail for effective test execution and management. Specifically, the standard requires a test plan to include items such as test items, features to be tested, features not to be tested, approach, item pass/fail criteria, and suspension criteria. A professional test analyst would leverage these sections to articulate a clear rationale for the chosen testing strategy, ensuring that it is directly linked to the project's quality goals and identified risks. This systematic approach ensures that the test plan is not merely a document but a strategic tool for achieving quality objectives, thereby fulfilling professional responsibilities under the ISTQB framework, which promotes structured and effective testing. An incorrect approach that focuses solely on documenting every conceivable test case without regard for risk or impact fails to adhere to the spirit of efficient and effective testing. While it might appear thorough, it can lead to an unmanageable test plan, wasted resources, and a dilution of focus on critical areas. This deviates from the practical application of the IEEE 829 standard, which, while comprehensive, is intended to guide testing efforts strategically, not to create an exhaustive, impractical document. Another incorrect approach that omits critical sections such as suspension criteria or item pass/fail criteria creates ambiguity and potential for subjective decision-making during test execution. This lack of clear definition can lead to disputes about test results and a failure to meet the standard's requirement for objective evaluation. It undermines the test plan's role as a definitive guide for the testing process. A further incorrect approach that relies on informal discussions and undocumented decisions for key aspects of the test plan, such as the testing approach or scope, directly violates the IEEE 829 standards requirement for a formal, documented plan. This lack of formal documentation makes it difficult to track progress, ensure consistency, and provide evidence of due diligence, which are essential for professional accountability. The professional decision-making process for similar situations should involve a thorough understanding of the IEEE 829 standards requirements, a robust risk assessment of the project, and a clear understanding of project constraints. Professionals should prioritize documenting the rationale behind their decisions, ensuring that the test plan is a living document that guides effective testing and risk mitigation. This involves a continuous evaluation of what is essential for achieving the project's quality objectives within the given constraints, always referencing the established standards and best practices. Question 17. Investigation of a new online trading platform for a UK-based financial institution reveals a regulatory requirement to ensure the integrity and accuracy of all transaction processing from initiation to settlement. The test analyst is considering how to best address this requirement within the overall test strategy. Which approach most effectively satisfies this regulatory mandate? Option A. Prioritize performance testing to ensure the system can handle high volumes of trades without degradation, as this implies functional correctness. Option B. Conduct system integration testing, SIT, to validate the end-to-end flow of transactions and data across all integrated components, ensuring compliance with regulatory data handling and processing rules. Option C. Primarily focus on component testing to ensure individual transaction processing modules are robust. Option D. Rely heavily on user acceptance testing, UAT, to confirm that business users can successfully execute trades. The correct answer is C. Primarily focus on component testing to ensure individual transaction processing modules are robust. Explanation. This scenario presents a professional challenge because the test analyst must balance the need for thorough testing at different levels with the regulatory imperative to ensure that critical financial system functionalities are validated against specific, auditable requirements. The challenge lies in interpreting the scope and intent of regulatory guidance concerning the testing of financial services software, particularly when it intersects with different test levels and types. Careful judgment is required to ensure that testing efforts are not only technically sound, but also demonstrably compliant with the spirit and letter of the regulations. The correct approach involves a structured testing strategy that explicitly maps test types to the appropriate test levels, ensuring that regulatory compliance is addressed at each stage. This approach is professionally sound because it aligns with the principles of risk-based testing and regulatory oversight common in financial services. Specifically, it ensures that system integration testing, SIT, is used to validate the end-to-end flow of transactions and data, which is crucial for regulatory compliance in financial systems. Component testing, while important for unit-level correctness, not sufficiently address the interdependencies and systemic risks that regulators are concerned with. Similarly, user acceptance testing, UAT, focuses on business user validation, which is distinct from the technical and regulatory validation typically covered by SIT. Performance testing, while a valid test type, addresses a different quality attribute and may not directly satisfy the regulatory requirement for functional compliance. An incorrect approach would be to solely rely on component testing to satisfy regulatory requirements for end-to-end transaction integrity. This fails because component testing focuses on individual software components in isolation, neglecting the critical interactions and data flows between these components, which are often the focus of regulatory scrutiny in financial systems. Another incorrect approach would be to assume that user acceptance testing alone is sufficient for regulatory compliance. This is flawed because UAT primarily validates that the system meets business needs from a user perspective, not necessarily that it adheres to specific regulatory mandates regarding data handling, security, or transaction processing logic. Relying exclusively on performance testing to meet regulatory compliance for functional integrity is also incorrect. While performance is a critical quality attribute, it does not inherently validate the correctness of functional logic against regulatory requirements. Professional decision-making in such situations requires a clear understanding of the regulatory landscape, the specific requirements of the financial system being tested, and the distinct objectives of each test level and type. A systematic approach, involving traceability between requirements, test cases, and test results, is essential to demonstrate compliance to auditors and regulators. Question 18. The risk matrix shows a high likelihood of sensitive customer data being exposed during manual test case execution if appropriate data handling measures are not implemented. The test team is considering several approaches for populating test data for manual execution of the customer account management module. Which of the following approaches best ensures regulatory compliance and ethical data handling practices? Option A. Create test data using generic placeholder values like test user and 12,345 for all fields, assuming the focus is on functional logic rather than data realism. Option B. Use a small sample of actual production data with a developer's verbal confirmation that it will be deleted immediately after testing. Option C. Employ synthetic data generated specifically for testing purposes, which mimics the structure and characteristics of production data without containing any real customer information. Option D. Utilize a subset of anonymized production data that has been scrubbed of all personally identifiable information, but retains realistic data formats and values. The correct answer is D. Utilize a subset of anonymized production data that has been scrubbed of all personally identifiable information, but retains realistic data formats and values. Explanation. This scenario presents a professional challenge because it requires balancing the need for efficient test execution with the imperative to adhere to regulatory compliance, specifically concerning data privacy and security as mandated by frameworks like GDPR, General Data Protection Regulation, when dealing with sensitive customer information. The test analyst must ensure that test data used during manual execution is handled in a manner that prevents unauthorized access or disclosure, even in a testing environment. Careful judgment is required to select test data that is representative of production data without exposing actual sensitive information. The correct approach involves using anonymized or synthetic data that accurately mimics the characteristics and format of production data without containing any real personal information. This approach is ethically sound and legally compliant because it directly addresses the regulatory requirement to protect personal data. By employing anonymized or synthetic data, the test analyst ensures that no actual customer data is processed or exposed during manual test execution, thereby mitigating the risk of data breaches and non-compliance with data protection laws. This aligns with the principle of data minimization and privacy by design, which are core tenets of regulations like GDPR. An incorrect approach that involves using a subset of production data, even with the intention of deleting it afterward, poses significant regulatory and ethical risks. This action directly violates data protection principles by exposing real personal data to a testing environment, increasing the likelihood of accidental disclosure or unauthorized access. It demonstrates a failure to implement adequate safeguards for sensitive information, which can lead to severe penalties, reputational damage, and loss of customer trust. Another incorrect approach, which is to rely solely on verbal assurances from developers that the data is not sensitive, is professionally negligent. This approach abdicates the test analyst's responsibility to verify compliance and data security independently. It fails to establish a documented, auditable process for data handling and relies on subjective interpretations rather than objective controls. This can lead to unforeseen breaches and noncompliance, as the analyst has not actively ensured the integrity and security of the test data. Finally, an incorrect approach that involves creating test data with placeholder values that do not accurately reflect the format or complexity of production data, while seemingly safe, can lead to incomplete or inaccurate test coverage. This may result in the undetected failure of critical functionalities in the production environment, which, while not a direct data privacy violation, can still have significant business and regulatory implications if the system's failure leads to data corruption or loss. The professional decision-making process should involve a proactive risk assessment of test data usage, prioritizing regulatory compliance and data security. This includes understanding the specific data protection regulations applicable to the project, implementing robust data anonymization or synthesis techniques, and maintaining clear documentation of data handling procedures. When in doubt, consulting with legal or compliance officers is a crucial step to ensure adherence to all relevant laws and ethical standards. Question 19. The risk matrix shows that the financial transaction processing module has a high probability of critical defects related to data integrity and calculation accuracy, and a moderate probability of defects related to user session management. The development team has provided a tight deadline for testing. Which combination of test case design techniques would best address these risks while adhering to regulatory expectations for financial software? Option A, equivalence partitioning and boundary value analysis only. Option B, equivalence partitioning, boundary value analysis, and state transition testing. Option C, use case testing only. Option D, exploratory testing and ad hoc testing. The correct answer is B, equivalence partitioning, boundary value analysis, and state transition testing. Explanation: this scenario is professionally challenging because it requires the test analyst to balance the need for thorough testing with the constraints of limited time and resources, while also ensuring compliance with regulatory expectations for software quality in a financial services context. The pressure to deliver quickly can lead to shortcuts that might compromise the integrity of the testing process, and, consequently, the reliability of the financial application. Careful judgment is required to select test case design techniques that maximize defect detection within the given constraints, adhering to the principles of risk-based testing and regulatory compliance. The correct approach involves prioritizing test case design techniques that are most effective in identifying critical defects based on the identified risks. Given the financial services context, regulatory bodies often expect a high degree of assurance regarding data integrity, security, and accuracy. Equivalence partitioning and boundary value analysis are fundamental techniques that efficiently cover input domain variations and edge cases, which are crucial for financial calculations and data entry. State transition testing is particularly relevant for applications with complex workflows or states, such as transaction processing or user session management, ensuring that all valid and invalid transitions are handled correctly. Decision table testing is ideal for complex business rules and logic, which are prevalent in financial applications, ensuring all combinations of conditions and actions are tested. Use case testing focuses on end-to-end user scenarios, ensuring the application functions as intended from a user's perspective, which is vital for customer-facing financial platforms. Combination of these techniques, guided by the risk matrix, provides a robust and compliant testing strategy. The regulatory expectation in financial services is not just about finding bugs, but about demonstrating due diligence and ensuring the software's reliability and security, which these techniques collectively support. An incorrect approach would be to solely rely on exploratory testing or ad hoc testing. While these can uncover unexpected issues, they lack the systematic coverage and traceability expected by regulators. Exploratory testing, without a structured basis, can lead to inconsistent coverage and may miss critical boundary conditions or complex logic paths, failing to provide the auditable evidence of thoroughness required in a regulated industry. This approach risks not demonstrating due diligence in risk mitigation. Another incorrect approach would be to exclusively use equivalence partitioning and boundary value analysis without considering other techniques. While these are essential, they might not adequately cover complex business rules or state-dependent behavior. For instance, a financial application with intricate loan approval logic would require decision table testing to ensure all rule combinations are tested. Similarly, a system managing user sessions with different privilege levels would necessitate state transition testing. Relying only on input-based partitioning would leave gaps in testing the application's logic and behavior, potentially leading to undetected defects in critical areas, which is a regulatory failure. A further incorrect approach would be to focus only on use case testing for all aspects of the application. While valuable for end-to-end functionality, use case testing might not delve deeply enough into the internal logic or specific input validation required for individual fields or calculations. For example, testing a single input field for a monetary amount would benefit more from equivalence partitioning and boundary value analysis than a broad use case. Over-reliance on use case testing without supporting techniques can lead to a superficial understanding of the application's robustness and a failure to identify defects in the underlying components, which is a compliance risk. The professional decision-making process for such situations should involve a thorough understanding of the application's domain, the identified risks from the risk matrix, and the specific regulatory requirements applicable to the industry. The test analyst must then select and combine test case design techniques that provide the most effective and efficient coverage for those risks, ensuring that the chosen techniques are justifiable and can be documented to demonstrate due diligence and compliance. This involves a risk-based approach to test design, where the rigor of testing is proportional to the identified risks and regulatory expectations. Question 20. When evaluating a proposed test procedure for a critical system, a test analyst identifies several potential safety risks and deviations from established compliance guidelines that have not been adequately addressed by the development team. The project manager, under pressure to meet a tight deadline, instructs the test analyst to proceed with the procedure as written, stating that these issues will be handled in a later phase. What is the most ethically and professionally responsible course of action for the test analyst? Option A. Execute the test procedure, but omit the test cases that specifically relate to the identified safety risks and compliance deviations. Option B. Proceed with the test procedure as instructed, assuming the development team has already considered and accepted these risks, and focus on executing the remaining test cases. Option C. Silently modify the test procedure to address the identified risks before execution, without informing the development team or project manager. Option D. Document the identified risks and concerns thoroughly, formally escalate them through the appropriate project management and quality assurance channels, and refuse to execute the procedure until the risks are adequately mitigated or formally accepted with documented justification. The correct answer is D. Document the identified risks and concerns thoroughly, formally escalate them through the appropriate project management and quality assurance channels, and refuse to execute the procedure until the risks are adequately mitigated or formally accepted with documented justification. Explanation. This scenario presents a professional challenge because it forces a test analyst to balance the immediate need for a test procedure to proceed with the ethical obligation to ensure the procedure is safe and compliant, even when faced with pressure. The core of the challenge lies in the potential for a flawed procedure to lead to unsafe conditions or noncompliance, which could have significant consequences for the organization and individuals involved. Careful judgment is required to avoid compromising quality and safety for expediency. The correct approach involves documenting the identified risks and concerns regarding the proposed test procedure and formally escalating them through established channels. This demonstrates adherence to professional testing standards and ethical guidelines that prioritize safety, quality, and compliance. By clearly articulating the potential negative impacts of the unverified procedure and seeking a resolution that addresses these concerns, the test analyst upholds their responsibility to the project, the organization, and potentially the end users or public. This aligns with the ISTQB principles of acting with integrity and professionalism, ensuring that testing contributes to the delivery of quality and reliable software. An incorrect approach of proceeding with the test procedure without addressing the identified risks is ethically and professionally unacceptable. This failure to escalate concerns directly violates the principle of due diligence and could lead to the deployment of a system that is unsafe or non-compliant. The test analyst would be complicit in any negative outcomes resulting from the flawed procedure, potentially facing professional repercussions and damaging the reputation of the testing profession. Another incorrect approach of unilaterally modifying the test procedure without proper authorization or consultation is also professionally unsound. While it might seem like a proactive solution, it bypasses established change control processes and could introduce new, unforeseen risks or conflicts with other project requirements. This undermines team collaboration and can lead to inconsistencies and a lack of accountability. A third incorrect approach of ignoring the concerns and assuming the development team has already accounted for them is a dereliction of duty. The test analyst's role is to identify and report potential issues, not to assume they have been resolved without verification. This passive stance fails to protect the integrity of the testing process and the quality of the final product. Professionals should employ a decision-making framework that prioritizes risk identification, clear communication, and adherence to established processes. When faced with such dilemmas, the steps should include: 1. Thoroughly document the identified risks and their potential impact. 2. Clearly communicate these concerns to the relevant stakeholders, including the development team and project management. 3. Propose solutions or request clarification and verification of the procedure. 4. If concerns remain unresolved, escalate the issue through the appropriate organizational channels, following the defined escalation path. 5. Maintain a record of all communications and decisions made. This structured approach ensures that ethical considerations and professional responsibilities are met, while contributing to a robust and reliable testing outcome.